We are back. This is Winter Data Meetup, and our next speaker is Sridhar, and he will tell everything about Snowflake. So, if you haven't heard about it or didn't have enough experience with Snowflake, hope this talk will bring you enough knowledge. So, please enjoy. Sridhar, floor is
Yeah,
yours.
thank you, Alexander. Hi, all. My name is Sridhar Pothamsetti. I'm working as a lead software engineer in EPAM systems. I'd like to explain about Snowflake and its implementations, how it can be used, what all the features it is giving to us as part of this data winter meetup, as part of the datagen community. So to speak about myself, my name is Sridhar Pothamsetti, as I said, and I have total 13 years of experience, and I'm completing 13th year today. And I got chance to work on multiple domains like banking and financial services, telecom, retail, and logistics. And tech stack is mainly into like big data, GCP, Azure, AWS, Databricks, Snowflake, and data warehousing related technologies. So I carry a good amount of experience in migrations and implementations from scratch with respect to big data and cloud with respect to the data engineering. So to start with, like anybody like here having like some experience on Snowflake or like got chance to work on the Snowflake.
Yeah, looks like our audience had some experience, but not deep,
Okay.
and half heard about it.
Okay, so I'll try to explain in detail from the theoretical perspective and how we can take it forward to the next level by working on these things. So moving towards the contents, what all the things I'll be covering today is like mostly Snowflake overview and how it transformed from the previous traditional technologies to now, and then the Snowflake architecture, the data organization, and then the key features, Snowflake integration benefits, and then the use cases we do have, and what are the best practices we can follow, and what all the upcoming features are in line, and what are the limitations we do have when we are using the Snowflake. Okay, so to start with, Snowflake overview, like what exactly is Snowflake? So as part of the data world, we work on multiple technologies like traditional warehouses, data lakes, and all these things, right? So Snowflake is actually a modern day warehouse or like lake house. We can say like recent days it got transformed into lake house because of the introduction of few programming related things and all. So it is actually a cloud data warehouse built on the top of the public cloud infrastructure. So we do have public cloud like AWS, Azure, GCP, and yeah, it's actually a true software as a service offering. Okay, so when I say software as a service offering, there is nothing to install or like nothing to configure, something like that. So directly Snowflake will be providing us the service. We can create an account, we can log into it, and then we can start using it by selecting the power we want to use, like the storage, the compute, and all these things. So it's actually maintained completely by the Snowflake, and it's like easy to use service. So what are the things it will be supporting? Like, so it provides a single platform for all the different types of workloads in the data world. So the first one is like data warehousing, data lakes, and then the data engineering, data science, data application development, and the data sharing in secure mode, and also the like consumption of the real-time data and like sharing it across. So if we see, like we call it as a data cloud data platform because of all this support it is providing from the data perspective. So the slide I'll be covering in the next slide. So I'm moving ahead with the next one. So how the journey is like transformed from the existing traditional on-premises based enterprise data warehouses into the current cloud data platform or current cloud lake houses. So the first one is like on-premises EDW. It's like Teradata, Netezza used to be there, and people started using those things in the olden days, right? So because we worked in the on-premises environment, we don't have the ability to take all the data, and also it's extract, transform, and load, right? So mostly we will be transforming the data and we will be loading the transform data only. So because of that, all the data is not available, and all users, we will not be able to give access to all users because it is need to know basis, and like we will be able to share with the corresponding users only, and it's not like available everywhere in the world. So next one is like on-premises based enterprise data warehouses generally support fast answers because of it transactional support and all, and also SQL database kind of functionalities available there. It's the same case with first generation cloud EDW also, the third one in the screen. So it is like Redshift when it is implemented in the initial days. It has some flexibility compared to the on-premise EDW, but still the all data and the all users problem was there. And when it comes to the data lake, we can load all the data. It's like ELT, right? Extract, load, and transform. So we can load all the data. And from the user's perspective, again, it does have the problem of sharing all the data across the world, and everybody can't access it from everywhere, right? And fast answers, it is because of the batch processing. We are not able to get the fast answers. It is mainly for the batch processing purpose. And then SQL database kind of functionality is not there, and it is like schema on read. So like when we are reading, then only the schema will be tested and all these things. So coming to the cloud data platform, it solves all these problems. Like we can share all the data with all the users, and we can load all the data, and we can get the fast answers because of the transaction support. And we do have SQL and SQL support for this one. So the journey is like the transformation happened from the on-premise data warehouses to the current cloud data platform, or like we can term it as lake houses also these days because of the introduction of Snowpark and all these things into the environments. So moving to the Snowflake architecture, how is it different from the existing things, right? So as I said, it supports all the public cloud infrastructure like AWS, Azure, and then GCP. So our data can be stored in any of these clouds. So it is like cloud agnostic layer we do have, and centralized storage. We can have common storage for all the services we want to use, or like all the data workloads we want to use. And multi-cluster compute, we can get the virtual warehouses as part of this compute in t-shirt sizes for different workloads. So might be like I'm from the data warehousing team and I need a small cluster, so I can take it, and there is another person who want to use it in the form of interactive mode, and he need the small access x small size. So then he can get the that size of compute for his purpose. And another person from the data science team, they want the more powerful cluster, so they can get the more powerful cluster as part of these virtual warehouses. And it can scale out in the form of multiple clusters, and also it can scale up for the existing machines also. So if you see here, Snowflake provides us the services of optimization, management, transactions, and security and governance, metadata management internally, and then sharing and the collaboration. So here we can discuss about the Snowflake architecture components. So if we see, we start from the down layer, which is the database storage. Whenever we want to store the data from like our local machines, or like from different clouds, or like from external machines and all. So we like Snowflake, what it will do is like it will try to reorganize the data. It will optimize it. It will compress it, and it will store it in the format of columnar data. And the micro partitions will be stored so that like the data can be fetched faster. So Snowflake actually stores this in optimized format, as I said, and it take care of all the optimization needed to provide the data back. And from the query processing perspective, we have a processing layer. So here the concept of virtual warehouses comes, and it will help us to process the data for the different types of workloads. So on the same data, we can have multiple virtual warehouses created by different teams. Like as I said, my team is data warehousing, or another team data lake, another data science team is there. So they can create separate warehouses on the same data, and they can start querying the same data for their purposes, and it will serve all those. So each virtual warehouse is like a kind of massively parallel processing compute cluster composed of multiple nodes. As I said, they can be scaled out or scaled up accordingly based on the need of the users. And Snowflake provides services like in the form of cloud services layer. It is like providing infrastructure management. So when we get the account, like we can get the storage, unlimited storage, and then unlimited compute power, and also the optimization internally. Metadata management also happens in the form of Foundation DB. And then the security, like data at rest will be secured, and data in motion is also like secured. So it is like secured everywhere. And then authentication and the access control. So if you want to have different types of roles available, like security admin, account admin, and the custom roles and all we can create as part of this cloud services layer. So moving to the closer look of these architectures. So we do have traditional architectures like shared disk and shared nothing architectures. When it comes to the Snowflake, it is a hybrid version of these two. And in shared disk architecture, additional capacity actually requires the forklift upgrade. That means like if you want to add some capacity or if you want to migrate from one to the other, we need to take the whole data and we need to move it to the other system. And also like at the same time, if you want to do the read and writes, it will trouble the system. And also like if you want to do the replication, we need the external hardware. So from the shared nothing perspective, resizing the cluster requires redistribution of the data. In Hadoop also, when we add nodes and all, right, generally we try running the redistribution commands. So similar to that, we need the commands to redistribute the data or like resize it accordingly. And shutdown also is needed if you need the unloading of the data. And each like if we want to have like some dev cluster, test cluster, or high availability cluster, so then we need to have different copy of data. So like the data will be duplicated onto the systems if it is like a disaster recovery method, or like if we want to have another copy of these things. And also like if we have skewness and all, or like distribution is not even, so in that time we will be using the vacuum commands and all, right. So it needs shortened distribution for the performance perspectives. And when it comes to the Snowflake, as I said, it is a hybrid version of shared disk and the shared nothing architecture. It's like a multi-cluster on the shared data, where the data is stored on the public cloud, uh, through which the Snowflake account is being provided. And it is actually centralized, and the storage is like kind of scaled out mode. It needs to be, if it needs to be expanded, it can be expanded, and if it needs to be contracted, it can be done automatically. And even independent compute clusters provide us the ability to read and write at the same time. And accordingly, we can resize them instantly. If we don't need that much power, we can reduce it accordingly. And automated backup also is available because of this cloud provisioning. It is available in multiple zones and multiple availability zones and the regions. Because of that, we can have the automated backup running for our data and the processing. So, as I said, AWS, Azure, GCP are the major clouds which are supporting the Snowflake. Whenever we create the account, we can select which of these services we want to use. So, moving to the traditional versus modern data architecture. So, traditional data architecture, if you see, right, it's mostly complex and costly with multiple copies of data. So, we'll be having different services like coming in the form of sources like OLTP databases, enterprise applications, third party, weblog, IoT, etc. Right. So the data integration can happen with help of extraction, transformation, load tools, and then the change data capture or streaming. So the integration can happen in any of these ways. And then the data transformation can be done using different ELT tools or the techniques we have, like Hive, Spark, any of these things can be used to do the transformation. And then the normalization and aggregation will happen in the third layer, which is like loading the data into the data warehouses, data maps, data marts, and then the backups. And then the data will be like created for the reporting purposes or for the downstream systems like data science teams, and then like shared in the format of files for the final consumers. So this is like a kind of complex architecture which will be having like multiple copies of data available in multiple places, and storage and compute is tightly coupled here in the traditional mode. When it comes to the modern data architecture with Snowflake, as I said, right, the cloud is providing the storage and it's the common data. So if I choose my Snowflake account with Azure Cloud at its backend, so my data will be in Azure Cloud, and the same data can be accessed by different teams or different workloads. It's like data warehousing team, data lake team, data engineering team, and then we can share the data with other teams also. And it is available for faster processing purpose. Sometimes I might need it to be like in interactive mode, sometimes I need it to be processed in very powerful processing mode. It can be done very easily with the same storage, and just I need to change the compute power with the virtual warehouses. So if you see the diagram, it's like a very simple architecture, and the storage and compute is completely kind of decoupled, and users have the flexibility to choose their processing power accordingly. So moving to the next one, which is the data organization in the Snowflake. So whenever we want to use the Snowflake, the highest part, or like the top most object we'll be getting is like the account. So we can register for the Snowflake account and we will get the details. So, and inside that we go into the next level, it's database. Just like other databases, we can create the database and the corresponding schema. We can create schema also, and then inside that we'll be having the table, views, and stages objects. So in Snowflake, the new concept is stages. It will be helpful to act as an intermediate layer before loading it into the tables from external storage like cloud, Google Cloud Storage, or Azure Data Lake, or S3 storage. So the stage will act as an intermediate layer to load it into the tables. So if you see, the tables are of different types like permanent table, temporary table, transient table, and the external table. So I'll explain these things in better in the next slides. And these are exactly like the existing ones. And views are also like in the form of standard views, secure views, and the materialized views. And stages are available as like either table stage, user stage. Mostly what happens is like whenever we create a table, the table stage will be provided automatically. It is an internal stage available for us. And the user stage is also, if I create a user for my name or like my friend's name or Shrikant name, so like that. So we do have users created for the team, right? So in that scenario, we will get the user stage created automatically. But if we can create the external stages, or like the name stages explicitly. So whenever we have a file in our local and we want to load it into the system, we can use these stages and have the data available in the stage, and then we load it into the corresponding tables. So also we do have objects available in the form of file format. So we will be having like XML, JSON, Parquet, all these formats, right? So these are supported here. And we do have object of like sequences, which will be helpful for the creation of the sequence and or like surrogate keys and all these things. And Snowflake has support for stored procedures and user defined functions also. So this is more similar to the existing SQL systems, and I'll be covering the detailed features of these things. So the first one I want to cover here is like standard and the extended SQL support. So as part of this, if you see, it is like more familiar to the persons who is working on SQL. So Snowflake supports ANSI SQL support. So any data analyst who has knowledge of SQL, or any data engineer who has knowledge of SQL, can directly start working on it without much hassle. So the core data types supported here are just like other databases: int, float, char, string, boolean, date, timestamp. And there are complex data types which are like variant, object, and array, which supports the nested level of data, etc. So column level constraints also supported here, like primary, foreign keys, and then the unique constraint and not null constraints are available. Information schema is available for us to have all the metadata maintained in the system for all the queries we run, or for all the objects we create, for all the columns which we maintain in our tables. So all object level metadata or all account level metadata, including billing and all. So all these things will be stored in the information schema. So which we can use to understand and verify, like validate the things accordingly. And transactions are supported here, like in the form of auto commit and rollback. Resource locking is possible. And advanced DML statements are supported, like insert, update, delete. Multi-table inserts are there, conditional inserts are there, and merge statement is available. Windows functions like rank and all these things we have like available for the usage purposes. Statistical aggregates are supported. Stored procedures are supported. User defined functions in the form of like SQL or JavaScript based ones are supported. And if we have a hierarchical data, like we have different levels like parent, child, and then the next level. So if we have to maintain those levels in Spark and all, we don't have them readily available. We have to use different type of concepts to implement them, right? So Snowflake has provided it internally. So we can use the connect by class to use those things. So coming to the data loading to the Snowflake. So if we have to load the data into the Snowflake, we have different ways. So first one I want to start with is my like local file system. So I have my C drive or D drive, or like if I'm using Linux machine, I have some files in my local. So I can load those files into the internal stage of Snowflake using the put command. So I'll be like putting use the command put and then the d colon the file name, and then just I'll give the stage name. I'll create the internal stage before loading it, so the data will be available into the internal stage. And then after that I can use the copy command, like copy the corresponding data from the stage into the table. So my table will be loaded with this data and it is available for the querying purposes. So similarly, if my data is in not in local file system and it is in like external cloud, maybe like GCP, Azure, or AWS, so then I can create an external storage, external stage, and I should create the storage integration here. So the storage integration will be to access the cloud data, like if it is in S3 or like if it is in Azure. I need to have the integration created to access the data from those cloud storage, and then I can use the same copy command directly from the stage, external stage, into our table. If time permits, I'll be able to show that towards the end of the session. So once the data is again available in the table, we can start using it as part of our processing purpose in the further layers once the data is available. So next, the third one is like kind of continuous loading. So we have continuous data being loaded into some particular location. So we can have different queuing mechanisms which are available as part of AWS, GCP, or like Azure. We can use those, and we can have a snow pipe created, which will try to connect to that location where the files are coming in, or like the queue where the files are coming in. We can integrate it and we can start continuously reading the data. As soon as the file is available there, or as soon as the data is available there, Snowpipe will copy that into the tables. So here there is no need for us to create any virtual warehouse. Snowpipe will be taking care of that. So that provisioning will be done internally by the Snowpipe, but there will be extra charges or like extra billing for the Snowpipe usage. It is like out of what we use. So moving to the next level, so as I said, right, different file formats are supported here. So Snowflake actually supports this batch loading, continuous loading, and unloading of data also into the other tables. So file formats are CSV, JSON, Avro, ORC, Parquet, and XML formats. And compression is supported in the form of Snappy or like Jetlib. Snappy compression is mainly for the Avro, ORC, and Parquet, and Jetlib is for the ORC. So as I said, staging, we do have internal stages where the data will be loaded into the Snowflake, and the data will be maintained internally in the Snowflake only. And we will create external stages for this Amazon S3, Google Cloud Storage, and the Microsoft Azure Block Storage. So the command I have mentioned, right? So to use the copy command, we can do like this: copy into my table, and from this @ symbol we will use, or like @ symbol we use for the stages, different types of stages. So here, whatever the my external stage, this is an external stage created already, like create external stage, and the corresponding command will be giving the integration details and all. So we will take the files, we can filter the files whatever we want to load into the table. Those stage contains much more data, we can only select the small set of it and we can load it into the table. Okay, so continuous data loading from the files, we can use Snowpipe to load these micro batches of data, just like Spark. And micro batch source, it can be available in the form of internal stage, or it can be in the form of the external stage. So as I said, there is no need to like upfront create some warehouse, virtual warehouse or something like that. Snowflake internally provides these and manages these compute resources needed for this Snowpipe to be operated. So how can we access this data? So to explain this, we do have Snowflake web-based UI. Whenever we create this account, we will get this option to log in from the web UI. And we do have SnowSQL, which is similar to the command line clients we have available. And also we do have multiple partner connects available in the form of ingestion, ETL, or like business intelligence partners are available. And we do have data analytics partners, and then the security and the governance partners. So all these things I'll be covering in the later slide. And we do have connectors and the drivers available. So like if you want to connect to the Snowflake from Spark, and if you want to connect from Python and work on this data, it is possible using these connectors which are provided already. And ODBC and JDBC connectivity is also there. And we can integrate this with the Apache Hive Metastore. So it will be helpful if you want to use it as Hive Metastore in the form of when we are using with the existing things. Okay. So the next part is the change data capture, which is the major thing in our warehouse usage. Like we will be using slowly changing dimensions also to capture the changing data. So here streams is a concept which simplifies the usage of change data capture. So what happens is, like, whenever we create an object, stream object, it will try to capture what all the changes are happening in those tables. Like if it is having inserts, it will try to maintain the data. If it is like having updates, it will have that metadata maintained, and if there is a record being deleted, that data is also maintained. So only the stream contains the metadata, not exact data. So like if we see, right, so it does not maintain any data which is changed. It's just try to capture that particular offset and what all the changes are happening. And then when we apply this stream onto a table, all these changes will be applied onto that. Okay, so it is actually done based on the versioning history maintained in the table. So Snowflake maintains the history in the form of versions, right? So that particular data will be applied onto the target table. So all these, if I have a table which is being changed continuously, so all those things can be reflected onto the target table using the streams concept. So tables, stream tables are like of two types. So one is like a standard stable stream, which will track all the DML changes like inserts, updates, and deletes, everything. And append only table stream, it tracks only the inserts. So if you want to only just capture like my data is of type only appending, so then we can use this stream. So I'm moving to the data sharing concept. So as I said, right, data sharing is a major thing in the world of this data engineering, right? So what happens is, like, if I have a provider account, like I am the provider, so I have different types of tables, views, and all these things created. So I can share this particular view with another account, and that account can start querying this data in the read-only mode, and the charges only will be for their processing power or the compute power, not for the data stored, because data is already in Snowflake and it is being maintained and like maintained and paid by the provider. So consumer account will be only charged for the warehouse provisioning and processing. Okay, so one constraint here is, like, both should be belonging to the same region when we have to share this data. So this is the one constraint, and the access will be read-only access. Moving to the next one, backup and the recovery, and also the data replication part, which is the major thing for us. So in the world of data, so like the recent services which we are getting in the form of different clouds like BigQuery, or if we take Databricks, or like any recent warehouses or like lake houses, they are provisioning us the functionality of time travel, which will be like having the versioning in the backend. It will enable us to go back in time and query the data. So due to some reason, if my data is gone, I can go back and I can query that data, or like somebody updated the tables by mistake and I want to go back to the previous state of it, so I can travel back using the commands available, and I can get those particular records which are corrupted or like which are changed. Unwanted changes can be recovered. So time travel is option which enables us accessing the historical data that has been changed or deleted at any point. So querying, restoring historical data is like possible for the databases, schemas, and the tables. And data retention period can be configured at any object level. So while creating the objects, or like while having them created, so we can give the correct corresponding data retention period based on the type of edition we will be using. Like Snowflake has different types of editions available, like standard edition, enterprise edition, and then we do have virtual private Snowflake edition. So for these different editions, it will be like provided based on the type. So to use this time travel, we will be having extra storage costs because we have to maintain the multiple version of data. So if we are using Snowflake standard edition, the time travel option provides us 1 day to go back. And then if we are using enterprise edition, we can configure it from 1 day to 90 days. So if I select a Snowflake enterprise edition, I will have the ability to choose it to go back till 30 days or 10 days based on my system requirements, or like the way we configure our data warehouse. Okay, so time travel will allow us, but due to some reasons, my complete Snowflake system is down. So then there is a concept called as failsafe. So what happens is, like, it will provide us the ability to get the data back in case of like some system failure or any other big disaster uh, events happening. Okay, so in that scenario, we can reach out to the Snowflake support team, and they have the ability to go back for 7 days out of this time travel thing, excluding this 90 days or like the 1 day we configure. So it will go back for 7 days, and within the 7 days it is able to recover. And if the event happened and 7 days are crossed, then they are not able to recover this data. Okay, so like if we take anything, if we have a timetable and time travel enabled for 30 days, so 30 days plus 7 days failsafe period will be available for us to get this data. Okay, so Snowflake support team need to be involved for this, and accordingly based on our like 7 days period, we will be able to get that. Okay, so database replication is also supported. One major thing is like, as Snowflake is available on multiple clouds, right? So we can have this replication done on multiple cloud platforms and across regions and across availability zones and all this. So if you see here, we can replicate data across the Snowflake accounts, as I said, and then the regions and cloud platforms. I'll be covering the slide which will depict this cloud platform scenario. And here the replication is available at database object level also, and it supports the disaster recovery functionality for us. Okay, so moving. So these are the different types of tables available and how we can recover these things. So if my table is of type temporary, so it will be available till the remainder of the session. So till the end of the session it is available, and it doesn't support cloning option. And time travel is either 0 or 1, and failsafe period is 0 for these temporary tables. And in case of transient tables, until we explicitly drop the data, the table will be available, and it supports cloning. And also time travel retention period is like 0 or 1 for this, and failsafe period is 0. So temporary and transient doesn't support the failsafe period here. But when it comes to the permanent tables, if we take standard edition and enterprise edition, or like virtual private Snowflake edition, so these tables will be like completely available until we explicitly drop them. And this supports the cloning. Okay, so cloning is also one important thing, which is like a kind of having zero copy concept. I'll explain it towards the end. And time travel redemption for this standard edition table is 0 or 1, as we discussed, and failsafe period will be 7. So we can get 8 days in case of standard edition to get the data if it is corrupted or if any failover occurs, something like that. In case of enterprise edition, so if we configure it as 90, then we'll have a failsafe period of 7 days, and we can get the data back going back to 97 days. Okay, so we'll have coverage of 97. Okay, so moving to the next one. This is related to the data replication across regions and the cloud platform. So if you see AWS Snowflake account, it is present in the US West region, and the primary database is in the like provider account one, and consumers are in different regions. So the data is shared with two consumers, consumer A and consumer B. So for the usage purpose, this database is replicated onto the Azure East US2 region. So automatically region level coverage is also there, and also the cloud level. Like if due to some reason my AWS cloud is also down and the service is not available for 1 day or something like that, then Azure can start providing that. So this way, it is like a kind of better option if you want to have the data replication across different cloud platforms and different regions. Okay. So as I said, right, Snowflake has a good partner connect, and it supports different rich partner connect, as I said. So if you see data integration, we do have IBM Data Stage, Informatica, Talend, Stitch, Stream, SnapLogic, Trifacta. All the major data integration tools can be easily connected with Snowflake and have the data loaded or like take the data. So the integration is easy with the Snowflake, as they've already provided the connectivity. And when it comes to the business intelligence, like creation of the reports or like having the data provided in the form of cubes, or like having it presented for the management and all, we can use the different types of tools like Power BI, Tableau, Looker, Click, and all these things, right? So this integration is already available. And for the advanced analytics purposes also, like Databricks, Cubol, SAS, Spark, and all these things have already connectivity established. And security and governance is possible through Colibra, which is like a metadata processing. And then we have Informatica available, Alation is available for that. And from the SQL editor's perspective, as I said, we have a UI provided by Snowflake itself in the form of web link, and SnowSQL from the command line perspective, and dbeaver SQL workbench, which are third party ones. We can use those also to connect to the Snowflake and query the data. And from the programmatic interface perspective, we do have Python. So from Python we can connect to Snowflake easily and query the data, like update the data accordingly based on the needs. And SQL Alchemy connectivity is there: Node.js, Go, Spark, .NET, JDBC, ODBC. So this is like a kind of rich partner connect which Snowflake has. And before moving to the benefits, so like who are the competitors of Snowflake? So like in market, when Snowflake is introduced, like it like started capturing the market, and like Google Cloud also has its own version of it, like we call it as the BigQuery. And Databricks also has introduced this Databricks SQL recently, though Databricks is present in the form of data lake or data engineering world. So now the both the ends got connected from the form of data warehousing and the data lakes, and now Databricks providing it as a lake house completely with Databricks SQL and the generic version of the Databricks. And Snowflake also started with this warehouses, and also the Snowpark connectivity is also provided, so that this also can act as a lake house. And GCP has provided us the big lake, which will be providing again the lake house concept for us, integrating the both the data warehousing and the data lake. And AWS, and then Azure, all these people are like moving towards with their services provided. Okay, so the direct I can say like the comparison or the benchmarking is being happening on Snowflake and Databricks mainly, and they are like kind of competing in this world with their own major features provided to us. Okay, so what are the benefits we'll get by using the Snowflake? So it provides the modern security. It always has kind of always on encryption to keep your data watertight. And it is perfect for sectors like where we have like sensitive data, like banking, financial services, or like any other things which deals with this main security data. So it is one of the things which automatically supports, and this benefit we can get. And advanced analytics, we want to do some different types of analytics on like stagnant data or like real-time data streams. We can like provide the analytics in secured manner and governed manner. So high scalability perspective, as I said, Snowflake supports like unlimited number of workloads. By providing the compute power, we can just spin up the clusters on top of the data, and we can query it whenever we want. Very powerful machine, it is available like in the form of, as I said, t-shirt sizes, small, extra small, medium, large, XL, double XL. So like the power of these compute warehouses are also being increased in each and every version, or like with every release. So they are providing the more needed things based on the kind of workloads. Okay, and as I said, from the easy manageability perspective, uh, Snowflake like comes up with automatic provisioning of these warehouses and all. There is nothing we have to look at from the infrastructure side, or like we just have to design our warehouse, go ahead, load the data, and just start using it. There is nothing like optimization and all you have to do. So if you have to do the optimization also, or like clustering and all these things, you want to look at based on the type of distribution of data, like the what I can say, skewness and all. So then you should have around 1 terabyte data. Then you can go ahead and look into the clustering concepts and all. Otherwise, Snowflake will be taking care of these things. And also, they will provide the plan for these queries which are running. So this is like completely manageable, and strong accessibility is there. Like you can get the 24/7 access from everywhere, like anywhere from the world. You can easily access it. And what are the different types of use cases it supports? Like we can use it as a like a kind of low cost storage, just like other cloud services we do have, right? So we can have the data loaded and we can start querying on it. Okay, and we can have reports created on this data. So generally data warehouses enable multiple teams to create their reports on top of it. So because of the support, the transaction support and everything we do have, and also the analytical support we do have in this Snowflake, we can directly connect to it, and we can start providing the users quickly with faster provisioning to the users. Okay, and analytics, if we want to do some analytics, or like we want to provide some insights, or like we want to provide some trained models and all, we can use Snowflake for the provisioning of this data, like in the form of analytics or in the form of AI and ML processing. So it supports automatically. So these are the type of use cases we can use for maintaining the data and providing the users better experience. So coming to the best practices, so whenever we create these virtual warehouses, we can either set the auto resume and auto suspend. What happens is, like, when we enable the auto suspend, if you are not using the warehouse for 5 minutes or 10 minutes, it can get auto suspended. And whenever we run the query again from the worksheets and all, it will start the warehouse for us. Okay. And remove unused tables in the warehouses, because like whenever we create some tables, right, so it is for temporary purposes, something like that, and if we leave them, the cost will be added, right? So better thing is, like, if we don't want any tables, we can better drop them. Okay. So if we are sure, like, if this is not being queried for a large number of days, or like we can check those things, we can have those audits added, and accordingly we can maintain our system better. Okay. So it's always a good practice to remove the tables which we don't use, or like the intermediate tables and all we create for the temporary purposes. Okay. And caching is one more feature which Snowflake provides. So it is at the level of results, and also local disk cache is available and remote disk cache is available. So your cluster is a persistent cluster, then there is not much benefit we'll be getting. What sorry If it is not a persistent cluster, then we will not be getting much benefit out of this. But if you are using a persistent cluster, and if it is like we are running a query, and my teammate also querying the same data, so he can get the data from the result cache. So the result cache will be available for 24 hours, and no processing charges will be there for the data which we are fetching from the result cache. Okay. So this way it will try to give you the better costing things, also billing perspective. So we can use the cache to leverage the already existing results. If we already queried some huge table and we got the output, so that data we can rerun it, or like requery it multiple times, but without any charge. Okay. So these are available across Snowflake's independent virtual warehouses, and query results returned to the one user are available to anyone else also, like as I said. So other users also can get the same result cache based data when the other user is querying it. Okay. And Snowflake query profile will help you to identify what all the bottlenecks we have for the performance. And using this query profile tool, we can diagnose the slow running queries and we can modify them accordingly. Most of the times, as I said, optimization will be happening internally based on the data is stored and all. But if we have some corner cases and all, so we can use this Snowflake query profile tool, and we can provide the details. Okay. And auto scaling, as I said, right, if we are using like different versions of the Snowflake, multi-cluster warehouses are available in the enterprise edition. So these will be configured, like I can say that, okay, my query is taking long time and I want to go to this much power, like Excel power, or like I want to have four clusters running. So we can configure that, and based on the need of the resource hungry query you are running, or like load you are running, it will enable those clusters to run and automatically downscaled when it is not needed. Okay. So this auto scaling will help us a lot. We do have, as I said, scale up concept is there, scale out concept is there, and if you are using enterprise edition, we have multi-cluster warehouses which will support to automatically query these things, automatically started and stopped based on the configurations we do. Okay. So coming to the upcoming features, Snowflake generally provides us the new features continuously, like every month, or like based on their release cycle. So based on the last updates, what I see is like Snowpark optimized warehouses are like in preview, and once these things are like completely tested and used by the users, they will be available for the users completely in the form of GA, generally available for the, like I can say, completely available for the users. So new warehouse option provides 16x memory and then 10x cache compared to the existing warehouses for in this scenario. And they're also providing the support for the tables with masking policies and the row access policies from the security perspective, or like provisioning access to the users, or like uh, providing the data in the form of masking. So these things are in preview, and they will be added as a complete features in the upcoming days. And database replication is available, as I said. So they are adding the support to streams and tasks also. So we discussed on the streams. Tasks are like, for the orchestration purpose, Snowflake internally provides the tasks for us, and we can create the tasks to run and schedule them accordingly. Okay. So account replication UI. So like if you want to do the account replication at account level, so then we can use this replication UI. Again, this is still in your preview phase. So in upcoming days, it will be converted to the full feature. And column lineage in the access history. So like whatever the tables we are querying, the corresponding source columns and the corresponding source related objects, we can track the complete lineage of it, or like the column lineage, using this access history. So this feature is also currently in preview. And data dictionaries for the Snowflake marketplace listings is also available. So like wherever we need the data dictionaries, like for the different domains and all, so we can use these things which are provided out of box from the Snowflake. Okay. So coming to the limitations, like before, we used to have limitation of maintaining the unstructured data when Snowpark and other things were not introduced. So it is like kind of acting as a cloud warehouse only. Later, like as I said, with the introduction of the support for the unstructured data and all, it became like lakehouse, which takes all the data, which can maintain it. So but now there is like kind of no data constraint. So like if I want to load the data, as there is no limit that this much data only you can store on the Snowflake, you can load a number of files, something like that, and it will end up with like huge amount of billing for us. Okay. So because of this no data constraint, sometimes we end up with major billings and all. And no on-premise option is available. As I said, Snowflake is like a software as a service, so we can directly use it from web as a service, but not in the form of on-premise cluster or like on-premise service. Okay. So price escalations happen in few cases generally. So if we don't do the capacity planning or like the designing perspective, and we don't do the POCs, or like generally we do that, but in some scenarios what happens is like we try to use the standard in times of like when we are doing the POCs and all. But when we go ahead with usage of enterprise clusters and all, so there will be different cost changes, and that end up with we will be paying more as compared to the like existing scenarios or like the use cases we checked. Okay. So also compared to the Google or like AWS Redshift and all, the community is also less if we compare it with respect to the existing major cloud uh, users and all. So it is small community, and this is one limitation. And before going to the I think I do have a few minutes. Just I want to quickly show one thing from the demo perspective. I just want to show like whenever we want to create the Snowflake, we can go ahead and have the Snowflake account created. And as I said, right, so we will be provided with the details. So my account details are like JDA30064, and the region is like Central India Azure. So I can use these things. This is the UI. So we can use this UI to query the data. We can go back and start using it. So this is sorry, one second. So these are the worksheets we do have. I can query the data from the databases. So I can go ahead and create the corresponding objects for me. Like I can create the tables, I can create the views, I can create the schemas. And if I go into this data concepts, if I go into my corresponding database, I can have the corresponding schema created here, corresponding tables created here, and different types of roles created here. So we can go ahead and use these options from the UI. And we do have a similarly SnowSQL available here. So we can connect to this SnowSQL. We can have it installed. We can connect to this JDL30064 Central India.Azure, and I can log in as my user. And after that, just like general SQL, we can use the database and the schema. We can show the tables. We can create the tables. Okay, just like create or replace table, the columns, and then the format we want to store the data. And then we can query the tables. Also, as I said, right, the tables come with its internal stages. So if you see at the rate percentage, we can use it for the table stages. So directly I'm putting my local file, which is in my local machine. I'm putting this file into the table. Okay. So this is available in the stage now. And after that, when I run this copy command into this table, so automatically the data will be loaded, and I can query the data from the corresponding tables. Okay. So here, if I remove this at the rate percentage, I'm directly querying from the table. So the data is already loaded and is giving me the data. Okay. So that's all from my end. And coming back to presentation mode, I think I hand over it for the question and answers.
Sorry, I was muted. Yeah. Let's move to questions. We have them from our audience. So first question is, where is it? Yeah. Is there any difference or restrictions for Snowflake between cloud providers? Maybe some features are unavailable or something else.
Yes. So,
No.
like as I said, right, it is continuously improving its services. So, few services are not there in the initial days, and with every feature, they are adding the support. So, like now we see like data replication concept, it is not there for the streams and tasks, right? So then it is like adding it in the next phases. And Snowpark was not there in the initial days, which provides the support for the users, and now it is being added, it's in public preview. And unstructured data support was not there. So like I can say it is continuously evolving, and in the same way the other cloud providers are also continuously improving based on the features it has. Like one cloud is providing one service, so the other people are slowly replicating that, like from the BigQuery or like Big Lake perspective or like Databricks perspective or Snowflake perspective, they are coming with their best versions and providing it as a service. Then the other people also started using those services.
So yeah, based on your experience, what's the most fresh Snowflake version on which cloud provider? So you're using
So,
Azure?
so like I can say like Snowflake is provided as a service, right? So as a users, based on the need, we can take the Azure. Like generally, most of the times I use Azure recent days, and initially we use GCP. So GCP came into the field very late, and it doesn't have all the features supported in the initial days. So in that scenarios, whenever there are restrictions, we used to like decide on the features we need. Like when we are doing this planning and all, we need to see like what exactly we need. So like we are going for the GCP, but this event processing is available there or not for the, like the, if you are using AWS, Kinesis support is there, and to what level it is supporting. So that kind of research we have to do based on the functionality, and then we have to go ahead and use it. So from the versions perspective, like the SnowSQL and all, I do have the versions available, but this is a, as I said, right, software as a service feature. So there is no concept of feature, sorry, versioning and all. Like if we take the software like SnowSQL and all, we do have versions available, and we can use them for our integration purposes or like the querying purposes.
Mhm. Okay, yeah, we also have a question from Oleg. Yeah, so what's the reason of using Snowflake over GCP, taking account that GCP itself has all the components that Snowflake propose?
Yes. So generally, if we have to go quick to the market, like when we started, my personal experience is like when we started with the implementations and all. So if we have to go quick to the market with the help of Snowflake, it is providing the better billing in few aspects. So like Databricks is good in one aspect, like when our workload is of one type, and when we do this comparison and the benchmarking, few scenarios Snowflake is good. Like from the data warehouse perspective, GCP is providing us the BigQuery. Okay, and from like Databricks perspective, if we take, right, so it do has its programmatic interfacing and all. It's very strong in its aspect. So based on our workload, we need to do the like whenever we want to use the service, right? So being an architect, I'll be like trying to do the POC. I will see like based on my workload, my current system, or like if I'm migrating from the existing system, I will do the benchmarking and I will connect with the corresponding providers. I will see like which one will be giving me the best benefits for my requirements. So in our implementations, we did the same thing. So like we reached to the like Google team, we implemented a POC on it, and then we went to the Snowflake people. We took a POC and we see the comparison, like the benchmarking, with the POCs, and then we will go ahead and start using it. So from the features perspective, they will be having a number of features, but for my requirement, it depends on how I want to like how as a team or like how as an architect, how I will be proceeding further. So
Mm-hmm.
how much benefit I'll be getting out of the usage. So in most of the factors, for our implementations, Snowflake like did better compared to the existing legacy things, and then Databricks SQL also came into the existence and it also performed better. So based on the again the existing platforms, we chose the
Mm-hmm.
corresponding ones.
Yeah, we have some also related question. Can you compare Snowflake and Delta Lake? So maybe you have
Yeah.
the
So
experience.
Snowflake, as I said, right? So before we used to call it as like a kind of data warehouse because it supports the SQL mainly, right? So in the later phases, with the introduction of Snowpark, like integrating it with the IDEs, and we can use it from the different programming languages directly. It provides just like Databricks. So what I can say is like now it has the ability to provide the data lake concept and then the data warehouse concept. So it supports all the things inbuilt now. So we can have a unified lake houses just like Databricks, and we can process them here. So when we want to use data lake, mostly we will go for like AI ML workloads or the real-time streaming data or like the batch processing. So all those things are supported on Snowflake. So Snowflake evolved from a cloud I can say cloud warehouse into cloud data platform, and now like lake house, which is supporting all the workloads. So in my first slide itself I have mentioned like when we take the data warehouse mainly focuses on providing the business intelligence support in the form of SQL uh, without having support for the unstructured data and all. So as I said, it doesn't support in the initial days, but slowly with the features being added, now it is supporting all these things, and it evolved to be a lake house which is supporting the both the features, both the best features, supporting the AI projects, providing like support to the ML projects and all these things.
Mm-hmm. Also have a question. Do you know if how can Snowflake read directly from Kafka stream?
So right, okay, so I have shown you the slides how can we load the data, right? So when we are loading the data, we do have a concept of snow pipe. So we can integrate it based on the like if it is AWS Kinesis, if it is Kafka, or if it is like GCP PubSub or like Azure Event Hub. So that integration is available, but to what level we can see, and then we can implement it. From the support perspective, it do support the real time data, but it will be loaded into the Snowflake, and again the processing power we need, we can have the warehouses providing the data for the reporting purposes. So like if I want the real time report, definitely it will not be a kind of pure real time just like Apache Storm and all supports, right? It's not always. It is like a kind of micro batching based only, but this Snowpipe streams concepts enable it to read the data from like the event data, either
Mm.
from Kafka or either from the Kinesis or the PubSub and all. We can integrate it, and then we can have it like available to the near real time, just like other services too.
Mm-hmm. So also have question about uh, Snowflake cost of storage low, almost as pure as free, plus all power of a full SQL. Plus, no, it's not a question. Sorry, it's just a opinion of Ivan. Yeah, thank
Okay.
you. Also, we have. Uh, Let me check. Is there is replacement of delta live tables in Snowflake?
Sorry, can you repeat that?
Yeah, we also can open our platform StreamYard and see this question.
Okay,
Sure.
sorry. Yeah. So like if we talk from the Databricks SQL perspective, right? So the way it is implemented is we do have the concept of delta tables and having them scheduled like using autoloader, or like we can have these things scheduled based on the data we will be getting. So continuously we'll have the data loaded using autoloader and have these delta live tables processed, right? So in Snowflake, we do have the concept of streams and then the tasks, but like from the exact comparison perspective, we need to just check it and get back on that. So I'll try to revert on this
Mhm.
accordingly.
Yeah, and also question from me. Maybe you can suggest some websites or materials or books how to learn where I can learn the Snowflake
Yes.
deeper.
So like if we are from EPAM, right, so we do have internal trainings available, right? So using our learn portal, we can go ahead and register for the courses, and Snowflake has its good resources for the training, and we can register for that, and we can go for the certification Snowpro core and the corresponding data engineer certifications and all. But if we are external users, also we can go to the learn.snowflake.com, and whatever I have explained, right? So the practical implementation of these things are available. We can register for the data warehousing or like the corresponding data engineering courses, and then we can continue the course to complete the end-to-end suggestions of it, and then we can go for the Snowpro core certification, which will make us be ready for the implementations or like making us stand out as part of the process. So
Hmm.
mainly, yes. If you do have any questions, you can reach out to me in my LinkedIn, and I can be able to help you out with the further studies or some POCs if you want to go ahead further. So this will be helping you to do some POCs, or maybe like if you want to excel in this area along with
Yeah.
Databricks and
Mhm.
all.
Yeah. Thank you very much, Sridhar, for this interesting topic. Yeah, Snowflake is very popular. So yeah, thank you very much. We will have next talk in 13 minutes, and Nikolai will talk everything about data science, its power and its weakness. So stay tuned. Yeah, thank you. See you
Thank
soon.
you all. See you soon.